Hello everyone, welcome back to another video. And in this one I'm going to do a video showcase about a recent article I've published on my Medium blog, and it's about Levenshtein distance. And Levenshtein distance is a mathematical algorithm that allows us to find similarities between strings by calculating the distance of the string characters. And it's really good to find instances of process masquerading primarily, but it can also be used to obviously find typos, quoted domains, or anything that would require us to find some sort of similarity between strings. So I have generated a sample data set here that includes various instances of typos, quoted, process names. And what we're going to do is to see how we can use the algorithm on Splunk. And I recommend you to read the article. It's mentioned in the description because it also includes the download link to the plugin on Splunk's website where you can install it and then use the macro provided. So let's begin by parsing the image name, because right now it's a full path and we want to get only the image name. So I'm going to rex field. It's already saved here, so I'm just gonna do that. And let's use a sample for our demo, and we're going to target SVC host as our benign process. In a real world scenario, you would make obviously a list of processes that you're targeting to find. A good place to start is many of the processes under the System32 folder, but you can also use living off the land binaries, at least some of them anyway. But we're going to start easy here, and then we're going to call the macro itself. Make sure to use the ticks character and not the single quotes character. And we're going to compare our target to our 9. Eval, and then we're going to create the... We're going to grab the smallest value from the macro, and we're going to search for instances where it's greater than 0 or equals or less than 2, which is a rather tight value. I found that obviously even a single digit increase can give you much wider results, which it's not something that we necessarily want, so it's up to you. But yeah, let's move on. Let's do it like this one. So now basically what's going to show us is our benign process and the processes that are masquerading, attempting to masquerade. If you want to see the full path, I think we can just do like this. Yeah. And the distance is 1 because it found, like, all of those are 1 character distance away from the benign process, right? So SVC host, and then you have 5 VC host, or S with a whatever that is, VC host, dollar VC host. So it's like 1 change away from the benign process. I found that it's a really good method to use on threat hunts, but it's important to always consider that on production environments and large data sets, obviously you're gonna get quite a lot of false positives. So you need to prepare a strategy for that. You can either reduce the distance or target only very specific processes or exclude like whatever you want, but like all of the good stuff on threat hunting or detection engineering, you're gonna have to do some work to get to a final product. So it's a rather short video this time. Not much to cover here. Most of the value is in the written blog post this time, which is linked in the description. So, yep, thank you for watching. I hoped you enjoy, and I will see you next time.